Hey folks, welcome back. In this lesson, we're going to talk about auto-scaling and EC2 metrics. These metrics allow us to keep an eye on our deployments, respond to changes in our environments, and they are certainly a prominent topic on the DevOps Pro certification exam. So for the exam, it's important to just know the various metrics for auto-scaling and EC2. You may encounter questions where you're given metrics that don't even exist or they exist for another service. So just knowing the metrics for auto-scaling and EC2 will go a long way in filtering out obviously incorrect answers. So let's take a look at the available auto-scaling metrics. We have group min size, group max size, group desired capacity, group service instances, group pending instances, group standby instances, group terminating instances, and group total instances. So we can use these metrics during our deployments. We can keep an eye on our auto-scaling groups. We can also keep an eye on lifecycle hooks, group in-service instances, group pending instances, group standby instances. So these metrics are valuable when we have lifecycle hooks running. Now, EC2 has more metrics, so I'm going to cover some on the diagram, but I'm going to finish the EC2 metrics on the key concepts page. So probably the most familiar one is CPU utilization, which is the percentage of allocated EC2 compute units currently in use. Then we have disk read ops, completed read operations from all instance store volumes available to an instance. Conversely, disk write ops, completed write operations from all instance store volumes available to an instance. All right, so I'm going to open up the key concepts page. EC2 metrics continued. So we have disk read bytes, bytes read from all instance store volumes available to the instance. Disk write bytes, bytes written from all instance store volumes available to the instance. Network in, number of bytes received on all network interfaces of an instance. Network out, number of bytes sent on all network interfaces of an instance. So disk read bytes and disk write bytes can be used to determine the speed of an application. And network in and network out can be used to identify increases in traffic. Network packets in, network packets out monitors the number of packets sent and received on all network interfaces of an instance. Then we have status check failed instance, keeps track of whether the instance passed the status check within the last minute. And then we have the status check failed system. Now remember, we have an instance status check and a system status check. So the status check failed system obviously keeps track of whether an instance passed the system status check within the last minute. And then we have status check failed, which is a combination of these two previous checks. So it combines both and reports whether they passed. A 0 return is passed, a 1 is failed. Now, let's keep in mind that these are the metrics we have out of the box. And a little later in the section, we're going to cover custom metrics, which are very important to understand, and they certainly feature on the DevOps Pro Cert exam. Now, we'll return here, but let's go back to our diagram briefly. So these metrics can be used by the auto-scaling groups to scale in and scale out. We're configuring a CloudWatch alarm for our auto-scaling group. We set up a scaling policy, and in our policy we're going to use our metrics, and that's what will be monitored. So our CloudWatch alarms will trigger automatically based on the values of our metrics. So our alarms are associated with our scaling policies. Scaling policies are auto-scaling properties, that specify whether to scale a group up or down and by how much. Let's go back to our key concepts and let's talk about scaling policies. A scaling policy changes the capacity of the auto-scaling group using a scaling adjustment that we specify in the policy itself. And there are three different adjustment types: change in capacity, exact capacity, and percent change in capacity. So, change in capacity increases or decreases the current capacity of the group by a specified number of instances. Exact capacity specifies the exact number of instances we want, instead of just adding or subtracting to the current number. Percent change in capacity uses a percentage value instead of a specific number. So if we have 2 instances currently, we want to increase by 50%, that will add 1 instance. Increase by 100% would add 2 instances. All right, and we also have scaling policy types, which affect how our auto-scaling group scales up and down. We have simple scaling, which increases or decreases the current capacity of the group from a single scaling adjustment. And then we have step scaling, increases or decreases the capacity from a set of scaling adjustments instead of just one. Now, with simple scaling, after a scaling activity starts, for example, increasing the number of instances, the policy has to wait for the activity or health checks to complete and the cooldown period to expire before it can act on an alarm again. And cooldown periods are important to prevent auto-scaling from launching more instances or terminating more instances before a scaling event has finished executing. And we saw some of this in the previous section in the course. Now, with a step scaling policy, the scaling policy continues to act on any alarm, even if a scaling activity or health check is in progress. All right, let's go back to our diagram and let's take a look at our scaling policies in the management console. So let's go into auto-scaling groups and let's create an auto-scaling group. And I'm going to use an existing launch configuration. It's a Linux AMI T2 Micro. I'll click Next. And I'll call it ASG Metrics Lesson. I'm going to start with 1 instance, default VPC, subnet, no load balancer, so we'll skip advanced details. And here we go, configure scaling policies. Now, we've seen in previous lessons, keep this group at its initial size is useful for testing our lifecycle hooks, but we want to check out scaling. So let's scale between 1 and 3 instances. So our group min size is 1 and our group max size is 3. And here are our metrics, but we can get much more detailed here. Scale the auto-scaling group using step or simple scaling policies. So let's set up our scaling policy. So let's create a simple scaling policy. Add new alarm. We'll just disable notification. When average, that's fine. Let's just take a look at what we have here. CPU utilization, disk reads, disk write, network in, network out. So there are our EC2 metrics. Let's just keep CPU utilization greater than 80% for at least one consecutive period of 5 minutes. Create alarm. Take the action. We could add a number of instances or percentage of the group. And let's just add 1 instance. Likewise, for scale in, average CPU utilization is less than or equal to, let's say, 40% for one consecutive period of 5 minutes. And we will remove one instance. We've seen this before. How about a step policy? Scaling policies with steps continuously evaluate alarms as they are breached, even while a scaling activity or health check replacement is in progress. And that's a crucial difference between the simple policy and the step policy. So let's create a scaling policy with steps. So let's remove our alarm and create a new one. Okay, so the simple step scaling policy should be a review. So let's just cancel out of here and let's go ahead and create a scaling group with a step scaling policy. Again, we'll use an existing launch configuration, call it ASG step, start with one instance, and let's just use all of our subnets. Configure scaling policies, and we want to use scaling policies to adjust the capacity of the group. Scale the auto scaling group using step or simple scaling policies. So let's scale between 1 and 5 instances, and let's add a new alarm. I'm just going to remove the notification. Average CPU utilization is greater than, let's say, 40%. Create alarm. We can start to add steps. Add steps to scale your auto scaling group based on the magnitude of the alarm breach. So let's add a step. First of all, CPU utilization is greater than or equal to 40. Let's scale up one instance. Let's scale up 2 instances, and then we provide an upper bound for the step. If we're below 40% utilization, nothing happens. Between 40 and 50, one instance will be added. Let's add another step. So between 50 and 60% utilization, we're going to add 2 instances. If we go over 60, we're going to add 3 instances. And again, the key point is the step scaling is kind of impervious to health checks, or it's not waiting. There's no wait here. At any time when these alarm metrics are hit, the instances will be added. Likewise, we can remove instances. So let's create a new alarm for decrease. CPU utilization, let's say less than 40. Less than 40, we will remove one instance. Add another step. If we get below 30%, let's go ahead and remove 2 instances. And I think we see where it's going here. Less than 20%, remove 3 instances. That's it for configuring a step scaling policy. Let's click Review and create auto scaling group. And we can view our creation log. Everything looks good. View auto scaling groups, and it's going to go to the desired. It's going to go to 1, and just like a simple scaling policy, it's monitoring our CPU utilization. So just to recap, the key point for step scaling policies. The scaling policy is going to continue to act on any alarm, even if a scaling activity or a health check is in progress. So this type of policy allows us to reply to breaches in alarms more aggressively depending on how big of a breach it is. So again, it's impervious to cooldown periods or health checks. It's always on the job, it's always monitoring, and it will scale whenever any alarms are breached. Now, another key point with step scaling is that we can specify an instance warm-up time with our step adjustments. This will make the auto-scaling group add the newly launched instance to the size of the group, but without including the instance in the group's CloudWatch metrics. So even with multiple alarm breaches, auto-scaling does not add more instances than it needs. So if our first alarm is breached and we start adding one, and then quickly our second alarm is breached, and we want to add 2 total, that first instance that was launched is taken into account. So we're going to end up with 2 new instances, not 3. Now let's talk about a use case. Well, it's really a problem. Let's say we're using EC2 instances in an auto-scaling group to serve our web application through a public-facing load balancer that receives requests from clients. Now we have a problem. Our auto-scaling group is not adding new instances proportionately compared to the amount of incoming traffic and the auto-scaling policy that was created. Instead, it's adding too many instances, which is adding unnecessary cost. So how would we fix this? And this is a common problem. We can publish custom metrics with the elapsed time since an instance launched to the time the instance responds to an ELB health check. Then we can adjust the pause time and cooldown property of our auto-scaling group to be greater than the value of our new custom metric. And we can perform this adjustment periodically. But this will greatly alleviate the problem of scaling up too many instances. So with that, we have completed this lesson. We've looked at EC2 and auto-scaling group metrics, and also some of our options for auto-scaling group policies. So with that, go ahead and mark this lesson complete, and let's move on to the next.